All right, so today we're going to talk about exponential models. Exponential models are used to kind of describe real life phenomena, things that either grow or decay all the time. And so we're going to look at a couple of different examples of where we might use exponential equations to help us solve some real life problems. So here's our first scenario. We have 30 mice that are released into a wildlife region. The population of the mice increases at 25% each year. And the question is, how many mice will there be in 4 years? Okay. Well, one of the ideas that you could do is simply, okay, if it's going to increase 25% each year, I could take the 30 mice that I have initially, multiply that by 25%, which is as a decimal is 0.25. And then what I have to do once I got that answer, I would then have to add back on the 30 mice. Okay. Well, there's sort of a better way to kind of do this. If I factor out a 30 from both of these, I get 30 times 0.25 plus 1. Okay? So really what I have is I have 30 and then times really 1.25 when I add 0.25 and 1. So one of the quicker ways, instead of kind of multiplying by the percentage and then adding that back on, is to simply add or subtract the percentage to the number 1 and then just do that multiplication right away to get your answer. Okay? So if I calculate that out quickly, grab my calculator to do that, I've got 30 times 1.25, I get 37.5. Okay? So that's how many mice are now in the population, give or take, so probably 37 to 38, obviously, after 1 year. I would now need to do that again. So now I'm going to take the 37.5, multiply it by 1.25 again. And then I'd multiply it again by 1.25, and then again by 1.25. Okay? So the idea is I keep multiplying by this 1.25, in this case, 4 times. So there's kind of a quicker way to do that mathematically. And so what we're going to use is we're going to use what's called the growth formula. Okay? So a growth formula is going to be the population, so I'm going to use P of t, P meaning for population. We're going to use t as our variable because of time. Okay? It's after 4 years. And what do we need? Well, we need an initial amount. I'm going to call that A. A is what we call a parameter. It's not a variable in this problem. The variable is t. Okay? But A is going to have some meaning to the problem. And we'll talk about that in a second. So we get A. We got 1 plus that interest rate. Since it increases, we're going to add. We're going to add R, and R is another parameter in this problem. Okay, it's going to have a meaning. In this case, it's going to be this growth percentage, 25%. And then we're going to raise it to the t power. So there's our variable, parameter, parameter. They have some meaning to this problem, and our variable. Okay. So now when I substitute these things in, well, A is my initial amount, which is 30 mice. So P of t equals 30. 1 plus, my interest rate is 25%. Always write it as a decimal. 125, and then I'm going to raise that to the 4th power. Okay. So you can type that right into your calculator as it's written. So I've got 30 parenthesis 1.25 to the 4th. And I end up with about 73.24 mice. So I'm just going to round and say that P of 4, the population 4 years later, is about 73 mice. Okay. Maybe we could use a little squiggly line for approximately 73 mice. Okay. So again, a couple of key things with this. This A value, which we're calling a parameter, very important to understand the difference between a parameter and a variable. Okay? Variable is something that changes in the problem. The parameter is specific to the kind of story that's going on there. It basically helps you set up the function, the equation. Okay? And then we don't really work on the variable until we actually try to solve the equation. Okay, so the first parameter is A, stood for how many mice are initially in the population, so there was 30. And then the R in this case was our rate of growth, which was 25%, and the increase made it plus. Okay? And then we just multiplied and solved it out. All right, so we'll look at a second scenario. So in the second scenario, you have a boat worth 25,000. It loses value or the word we use is depreciates 15% each year. How much will it be worth in 5 years? Question mark. All right, so very similar scenario. You have kind of an initial amount instead of how many mice, we've got how much money. And we're still talking about it going up or down a certain percentage each year. And in this case, it's going to be after 5 years. So we're going to use that same equation. How much is it going to be worth? I'm going to maybe use C of t for its cost. So the cost of t, or the cost after a certain number of years, is going to be equal to A1. This time, since it depreciates or goes down, I'm going to subtract R to the t. Okay? And now I need to kind of fill in my parameters. So A in this case, again, is going to be my initial amount of the car or the boat, which is 25,000. So there's my parameter for that. R is 15%, so 0.15. And then T is going to be raised to the 5th power. Okay? So the idea here, when we subtract 1 minus 0.15, that's 0.85. What that means mathematically is that the boat holds 85% of its value. So each year the boat is worth 85% of what it was last year. Okay? And that's the idea of a little bit of exponential, is that you're always multiplying by the same number over and over and over again. So again, just going to use my calculator. Get that $25,000 initial amount multiplied by 0.85 to the 5th power. And the boat is now worth about C of 5 is $11,092.63. Okay? So you can tell the boat went down about 14 grand over those, 5 years. Okay? All right, one more scenario, we're going to look at banking and compound interest and how that is slightly different of a formula. For compound interest, your formula is going to be A, your initial amount, 1 plus our interest rate, but we're going to divide it by n. We're going to talk about that. And then we're going to raise it to the nt. So I could look at, m for money, how much money I'm going to have. Okay. So A is going to be my initial amount. R is still my interest rate. These two n's are actually the same thing, and what they tell you is how often your money gets compounded. Okay, so during a year, does your money get compounded daily? Then n would be 365. Every day, you kind of gain interest. Monthly, 12 months in a year. Quarterly, 4, because there's 4 quarters in a year. Okay, and if it was just annual, we could use 1. And if we put 1 in for n in both spots, we actually get that equation that we just used in the first 2 examples. Okay, and T still stands for our years. All right. So let's look at an example. Let's say you invest $2,000 at 5%. How much money will you have in 10 years if it is compounded? We're going to look at kind of three scenarios. So the first one we're going to look at is if it's compounded annually. Okay? So what this means is you put the $2,000 in, sits in your account for an entire year, and at the end of 1 year, they figure out how much interest they're going to give you and get you, your money. So only one time a year do they actually add money to your bank. Okay? All right, so let's figure this out. My money, M of t, is going to be equal to my initial amount, which is my $2,000, 1 plus, my interest rate is 5%, so 0.05. Now I'm going to divide. Well, annually means that once a year, so I'm going to divide by 1. And then I'm going to raise it to the n, which is 1, times t. So 1 times 5. If you're using your calculator for this, you got to be very careful. Okay? Either multiply the 1 times 5 together to get 5, or once you hit the exponent key, you need to put the 1 and the 5 in a parenthesis to make sure that you actually raise it to the 5th power and not raise it to the 1st power, and then multiply your answer by 5. Okay? So let's calculate this out. I get 2,000, 1 plus the 0.05 divided by 1, which is just 1.05, raised to the 5th power. And this should end up with about $2,552.56. So we're going to look at this and answer a couple other questions. We're just going to switch how often it's compounded, and we're going to kind of see the difference for it. So the next one we're going to compound is quarterly. I'm going to change this in my problem and make it quarterly. So I'm going to get my $2,000. 1 plus my 0.05. This time I'm going to divide by 4. Okay? The reason why they're dividing by 4 is they're going to give you, add money into your account every 3 months. Right? 3 months times 4, that's the 12 months. But they're not going to give you 5% every time. That would be a lot of interest because they're giving you 5%, 5%, 5%, 5% in 1 year. So what they're going to do is actually going to give you a fourth of your interest, or a fourth of the interest rate, at that first time, and then a fourth again, and a fourth again, and a fourth again, which is going to get you kind of that 5%. Okay, what actually happens, though, is you get a little bit more than 5% because you're making interest on your interest. So this number should pop up a little bit bigger. So now when I raise it, I'm going to raise it to the 4 times 5, or really to the 20th power. Okay, so I'm going to do the same thing, 2,000, 1 plus 0.05, divide it by 4, and then raise that to the 20th power. And I end up with $2,564.07. Not a huge change, but I basically have made, compared to the $2,552, about 12 free dollars. Okay, so 12 free dollars that I didn't have to work for. It wasn't my money that I invested. Okay, that was the $2,000. So I know, not a whole lot, but if I had a lot more money, it would be a lot more. Okay, so we're going to switch it one more time to monthly. This is the pretty common one. Okay, so typically banks are going to give your money and compound it monthly. So at the end of each month, you should get some extra interest added into your account. So what's going to change here is the ends. Part of my parameter changes. And now my exponent's going to be 60. So same idea, $2,000. And I'm going to change it to dividing by 12 and raise it to the 60th power. And end up making about 2 more bucks, almost 3. So I get $2,566 this time and 72 cents. So again, not a big difference, but that's about $14 more or so than my initial amount if I just compounded annually. Okay, so there's your ideas, exponential growth, using kind of your formulas, a 1 plus r to the t, or with compound interest, we have to divide the r by n, one of our parameters, which stands for how many times your money gets compounded. So this is number of compounds per year. Missed that earlier, my bad. So n stands for the number of compounds each year. It's annually, it's 1, monthly, 12, quarterly, 4, daily, they use, I think, 360 instead of 365. So that's how you basically model some exponential equations.